So first of all, thank you very much for inviting us here. It's our first time here in Gothenburg, I think. It's not your first time, but it's our first time
yes.
presenting. Yeah, that's it. So today we are going to talk about modern business applications in Java. This is not a typical Java user group talk, mostly because we are talking about a lot of concepts and the projects that we are working on, which are Java frameworks, but from more like from the conceptual point of view, in order to be able to show how to apply these projects into your real life and daily practice. We wanted to discuss a little bit about these concepts because we truly believe in the frameworks that we are building and how these frameworks can help you to build smarter applications, and also to bring in some methodologies to build better software in general, not just to have better technology, but just to have better methodologies to work and to keep working on software in the future.
Yeah, and on top of what just Mauricio said, even though it's a Java frameworks, we will not narrow it down to Java only. We will have in the demo a bunch of other technologies as well, like AngularJS or JavaScript frameworks, just to show that it's possible to integrate with pretty much anything. And even though it's a Java frameworks and those that we work with, but we consider them as tools only. And as you probably know, the tools will change anyway. So those kind of tools you can use today, you can use tomorrow, but in the end you most likely will anyway change them. So keep the conceptual thinking that we will present as the majority of the takeaways from this presentation. The tools and the demos are just to showcase that it's actually possible to implement and possible to use in practice.
Exactly. As engineers, we truly believe that these kind of methodologies are really, really important for us as another tools to build better to build better software. So it's kind of important for us, for you, and for you to take away this from this talk. We are both Java engineers, software engineers. We both work at Red Hat. But this is more like a community event, so we are just part of this community of the projects that we work for. The projects that we work for are JBPM and Rules. How many of you have heard about these projects before? You raise your hand. How many of you are using them? 2 guys. That's good. Yeah, we should have t-shirts.
Hopefully after, hopefully after the event there will be more.
Exactly.
Yeah, just quickly about us, that is not really important, but just so you know who we are.
Yep.
So my name is Maciej Siderski. I work as a principal software engineer at JBoss by Red Hat, and my main responsibility is actually JBPM. So I'm working as a core developer of JBPM and things around it for the execution server and so on and so forth. You will see a bunch of the JBPM stuff in the presentation and in the demo, actually running and doing some work. Of course, the demo is simple enough to actually showcase the concepts, but very easily to expand later on if needed.
Same on my side. I've started with JBPM. I kind of like get involved more with Rules nowadays, and I'm kind of like working in both communities in Rules and JBPM, like sharing the word about the projects, also working on the cloud side of it, kinda. So we will talk about that later. So the main idea for the presentation today is to cover some of the conceptual things behind the frameworks and why we are building these frameworks and why we are building all the tools around the frameworks as well. Because the projects that we are talking about nowadays, they are just not frameworks for you to use in your applications, but there is much more around them nowadays that it's becoming like a larger platform. So we wanted to share the main principles behind that. And we are going to start talking about how do we build software, how do you guys build software every day, and how is that changing. You might have heard about microservices and all the trending topics around the industry nowadays. We will be not talking about microservices in a specific, but we are going to be talking about some methodologies around how to build software and how we are used to build software and how we are used to design software in general. Then we will be talking about modern requirements, about what are the things that nowadays we should build into applications, and they are things that they are required, they are no longer optional things. And then how we can solve and how we can approach these things in order to maintain them in the future, not just to build them today and then in 2 years' time we need to rebuild everything from the scratch. And then how Rules and JBPM, these 2 projects, fits into that picture, and how all the infrastructure that comes with those projects also helps us to build different types of applications. At the end, we will take a look at the demos, trying to show you a little bit about how a real application will look like.
Yeah, and a bit of administration as well. We wanted to have it as interactive as possible. So please interrupt anytime when you have a question, comment, or you wanted to share your thoughts as well. So don't be afraid and share it as soon as you have.
Yeah, we weren't expecting like an auditorium kind of thing, so feel free to just throw your questions this way. So I wanted to start this presentation talking about a little bit about how do we used to build software in the past and how is that changing a lot and how these kind of tools that we are going to be showing helps in that direction. So we used to be, at least when I was in the university and when I went out and I started like working and doing my professional life, I realized that most of the time we just build solutions for specific problems, which is fine when you start. But at the end of the day, we are just focused on one solution. We are just focusing in solving a specific problem, and we are just focused in delivering that solution, right? Just from the beginning to the end, we know what the output will be, and we just work towards that. Okay, that's kind of like the traditional way of building software. Most of the time, what what are we solving is defined by the stakeholders or the company or the organization that requires that solution. But most of the time, they don't really know what they want. They don't really know what's the problem and how to solve it in the best way possible. And for that reason, while we are working on this, we realize that the solution is probably not exactly what we were expecting to build at the beginning. So the requirements changes a lot, and nowadays we need to be extremely flexible in how do we build solutions and how do we build applications. The other big problem is that when you start building one application, everything is fine. You can just create your project, choose your technology, and do whatever you want inside the project. But in reality, you go to companies and you need to develop in a very complex environment where you need to make sure that you use a similar technology stack, or if you choose something different, you know how to integrate against the legacy or all the other applications that are in that environment. So there is a lot of chaos when you try to start integrating with some other applications. There is a lot of chaos in defining how your application will look like in order to not duplicate functionality that it's already being covered by some other systems. How you don't duplicate models, or if you duplicate them, how do you keep consistency between them if you want to keep consistency? How do you avoid duplicating functionality again instead of reusing functionality? And yeah, incompatible technologies, you know, you need to really have some system engineers and system integrators that knows how to deal with all the technology mismatch and how to transfer data into different formats, communicate different systems. So the bottom line is that technology moves forward, our businesses and our companies also moves forward, meaning that our problems and our solutions needs to move forward as well. We can just not replace all of our software every 2 years when the new technology comes in, and we just want, as software developers, we just want to jump and use the new technologies, and at the same time, we can just not keep using the same old software that was developed 10 years ago for solving a 10-year-old problem, right? So we need to find a way to move forward and dynamically create more flexible applications that allows us to keep them changing to solve daily problems.
Yeah, what is as well important to keep in mind that we actually build software for a certain purpose. We're not building software just to build software, although some people do that. But the most important is that we actually start seeing the business value out of the solution that we built, and we don't focus on technology and the new frameworks and so on and so forth, and look from a bit higher perspective at the solution, why we actually build it, and does it really bring any value to the actual end users. Because this is a major thing that a lot of people just keep focusing on technology, selecting frameworks, selecting languages, chasing for the newest and shiniest thing in the industry, implementing stuff and so on and so forth. But in the end, when we go out to end users, they say, yeah, but fine, 10% of it is useful, but the rest is just waste. Why you actually build it and why you wasted time and money on this?
Exactly, and how do we explain users that they will need to wait for 2 years in order for us to develop a new solution in a new technology, and all those kind of questions that involves time and how fast we can deliver something, instead of how do we build better software that can be flexible enough so it can be changed for tomorrow. So this is a little bit more about modern requirements, which is exactly that. We are not enabled anymore nowadays to build software that it's a black box. that we can just build it from the beginning with some requirements and delivering it as we thought that it will be when we started the project. We need to deliver software that is flexible enough to be adaptable and composable and changeable, so it can be kept up to date with the daily requirements that a company might have. Another big thing mostly from governments and this kind of like large organizations, they definitely need operations transparency, where they can see what the software is doing, not in the sense of auditing, but in the sense of the business. So how many patients this hospital is managing every day, and in real time, how do we get that information about what the system is doing with these patients and what are the operations or the things that are related with that patient itself. So know what the software is doing and know what the company is doing with that software in order to understand what's happening with the company or with the business itself. And which brings us to the last point, which is getting real-time information about what's going on. So we should be able to get operation summaries and about what's happening and summarizing all that information in order to make decisions. So the management level of the companies, they need to make sure that as soon as their users are using a software, they need to be notified about how the software is being used and what's going on there and how the company is working every day. And at the same time, being able to resolve issues. Yes?
When you talk about apply quick changes in environment,
yeah.
Which agile methodology would you recommend?
Okay, we are going to talk about methodologies a little bit later. Again, this is not about how, so it is related with how you build software, and you can use any methodology that you want to build software, you can use whatever you want, but it's more about the features that you're going to provide in an application. So nowadays, if someone tells you, okay, I need to solve this and this problem, how do you build a solution that is flexible enough not to just solve those two problems, but to enable the company that is getting that solution to understand how your solution is working and how it can be changed to tomorrow solve a different problem, that it was not designed at the beginning.
Yeah, I would say that when it comes to methodology, it really depends on the team.
Yeah.
Because different teams will have different knowledge, different experience, different way of working. Mm-hmm. And this is actually what will drive the decision with methodology to choose. You should work with a teammate to make sure that you understand each other. And by a teammate, I mean the entire ecosystem of the solution that you're building, including business people, because they are the inventors of your modern requirements. The modern requirements actually are coming from the overall changing industries. Yeah. They constantly change, and the flexibility and readiness for change is extremely important right now. So we cannot go for a black box saying, yeah, this solution or this IT system will fix all our problems. And it's so generic that will secure everything. Yeah. That's not the case anymore. We need to have a really tailored solution that does perform certain activities and does perform those activities well. And this is what we're going to look at as well when looking at the different approaches and looking at the actual solutions that might help you with achieving the readiness for change and frequency of change.
Yeah, and take this talk about a little bit more about, okay, so you know Agile, you know microservices from the technology point of view, you know maybe domain-driven designs. Take this as a parallel approach that it's like, it can be worked, you can make everything work together. So you have your team methodologies, you have your technology, you have your principles for designing solutions, and then you have these that can be used as well in conjunction to that in order to make more smarter applications and things that can be quickly changed. Okay? Yeah. So going back to the modern requirements, it's how do we implement these modern requirements? How do we make sure that we just cannot create, that we just not create a black box software? How do we give to the company all the information that they need in order to make smarter decisions and to get all that information together and summarize from them when they need them? We have a couple of things, some approaches that will definitely help towards that. Starting by separating the business from the technology. This is the what, the business is what we are trying to solve, from the how we are solving it. So it doesn't really matter which frameworks, which technology are we using, it needs to be separated from the business definition. So what is the problem that we are trying to solve? We are trying to solve how we deal with patients in a hospital, how do we deal with mortgages in a bank, how we deal with productions of a car in a car manufacturing company, how do we deal with people in an HR department, right? All these kind of things are very business specific, so we can just definitely decouple that from the technology that we use to build the solutions for those problems.
Yeah, another important thing is to make sure that you understand that don't be afraid of diversity. Don't over-standardize. Like going for a certain area, if I have this domain, I will say, I'm going to build only Java applications, or I will build only JavaScript application, or .NET, whatever. Don't over-standardize on this, because the domain and the requirements are different. So don't be afraid of using different tools for different needs. And even though you standardize on certain things, they will get outdated. You will not be able to keep everything up to date with all the versions and progressing at the exact same time. So they will be different anyway. So don't try to go for an ideal world where everything is perfect and everything will smoothly move forward without any effort. Just use the right tool for the job, and if you keep that principle in mind, I think that you will be in a much better position, because you actually deliver something that works at the exact time that it's needed.
Yeah, if you start hearing about a lot of microservices and that kind of movement, you will see that those are kind of like the standard way of thinking, right? Just choose the right tool for the job perfectly, but how do we bring all together? How do we make sure that these microservices are going to be working in the next 5 years? How do we make sure that these microservices represent something for the company that is using them? And how do we adapt those microservices in order to reflect the company's changes, right? As fast as possible. So as soon as we manage to decouple the business from the technology, we can also start decoupling the development cycle of the solutions from the business definition cycle, meaning that people, the experts from the company, they can start refining how the problems are being solved, because the company is changing, so we need to make sure that they can refine and they can just improve and update as much as possible the definitions of what needs to be solved. And then it's mostly about common sense. Just try to work more on integration than in creating new software, trying to work more on updating existing software than creating something from the scratch, and try to make sure that you use the existing software as much as you can to solve new problems that will appear tomorrow. So for us, it's really important, and for a lot of methodologies, it's also really important to start creating like smaller projects, work iteratively instead of working in the final product, just working what can solve a problem for tomorrow, and don't over-engineer solutions. So the tools that we are going to show, they are in the system integration space, as you may know, but at the same time, they go with these principles quite strongly. They try to separate the business from the technology. They try to help you to integrate different tools together in order to build solutions, and they allow you to iteratively improve and change the definitions of what needs to be solved quite easily and in a very standard and methodological way.
Yeah, what might sound easy on the presentation, on the paper and so on, create small projects that you can work iteratively and so on. But in the end, it's very difficult if we focus on the technology only to build a solution that is small and composable, so to say. But when we start looking at it from the business point of view, then we clearly put the frames around it. And then we don't expand beyond those frames, because those are the business frames. Those are the capabilities of the system that the business requires, nothing else. Nothing else is really one of the most important principles where you apply to build a small project. Because then when having a small project, you can clearly say, okay, I can now change this very frequently without affecting much of the other ecosystem. But at the same time, keep in mind that changing it requires a downtime. And then if you have a downtime, other services might be affected because of that. So that brings yet another set of challenges that you need to keep in mind whenever you start building the smaller systems within your ecosystem. But at the same time, you can clearly and easily replace those because they are small. And the smaller it is, the easier it is to change.
And I know that we are going like very conceptually on these topics, but we will jump into the practical side in a little bit. So we wanted to share this because we think it's important, and it's not clearly when we see these projects, Rules and JBPM, and they both share this thing, which is knowledge formalization and automation. This is basically a set of methodologies and a set of tools that allows us to formalize what needs to be solved in a formal language, not just one, in several different formal languages. And then it allows experts to read those formalizations and to understand what's going on and how the problems are being solved. And because they can understand, they can work together into refining these models. And as soon as the models are mature enough, they can start automating these models and driving the company with this automation. And as soon as we run these models, we can automatically get information about the execution of the models. And that information is meaningful for the companies that are running those models, because that information is about how they are dealing with patients, who is involved with dealing with the patients, how many people do they need in order to deal with patients in hospital, and very valuable information from the company point of view. So it definitely, looking at that information, when you start getting that information from running these models, you start definitely having all the information in order to make decisions about bottlenecks or improvements in different areas. So we are going to see now in the demo how you can get all that information from the execution without knowing that that information is being collected, basically.
Yeah, we already started to go into the area of knowledge, and this is what we seen as the most important part of the modern business application, where the knowledge is in the core of your system. The knowledge that you capture from the business, this should be clearly referenced in the application to make sure that anyone who looks into it directly knows what it refers to. We should have a direct translation to the business entities of business knowledge that our subject matter experts actually use in their daily work, because that's what brings us closer to business, understand their needs, understand their problems, and the complexity that they have in the domain. The software industry should actually help them to simplify their complex behavior of the business with the IT tooling, not the other way around. We should not overcomplicate their businesses.
Yeah. We shouldn't add them more work on top of the work that they already need to be doing, right? We need to make sure that the tools that we build are solving their problems, and we are not adding any overhead on top of that. So there are well-known methodologies to work around these topics, and they are extremely related with knowledge formalization. At the beginning, when you start looking at BPM, how many of you have heard about BPM? Okay, so business process management.
How many people use BPM in any kind of form? Okay.
Yeah, it's a methodology, so it's not a software itself, and it's a set of tools. You can see BPM as a framework, as a methodology, as a lot of different stuff, as a standard as well.
Way of thinking, way of working.
Exactly, yeah. So, and that's kind of like an important practice. And as a software engineer, I do believe that that's kind of like important to have in your toolbox. It will not solve all your problems. It's not the magic. It's not magic. It's not.
Yeah, but it definitely should help you to understand your problems.
Yeah, exactly.
And then break them down into individual pieces that are more manageable than as the bigger picture.
Yeah, exactly. The same with decision management. How many of you have heard about decision management? Not much. Okay, that's not as popular as BPM, but it's getting bigger nowadays. And it's the same. It's how you formalize. In BPM, you formalize your processes, your business processes, basically how a set of activities needs to be performed in order to do something. The people involved in those activities and the systems involved in those operations. And decision management is about creating and formalizing decisions that can be repeatable in time. So again, both ways of mapping knowledge. And at the bottom, you have ontologies, which are like our models. For Java engineers, it's our models defined in a standard way and as a dictionary for them to use. So you can start mixing these methodologies. You can start mixing what these standards promote in order to start creating applications and tools that use them. Yeah, this is a little bit more complicated diagram, yes, but it's basically showing all the pieces together and how these kind of like systems around BPM, about decision management, how they work. You usually have, and then you will find this kind of stuff familiar because you are already doing some of these already. So we have our analysts, the actors there are experts and analysts working on defining this knowledge from the company. And they have a knowledge base, which might sound familiar, like Git, right? So every time that you create software, you just put it in a repository. You need to make sure that you can version that knowledge in the same way that you version source code. Then you have ontologies, or the models, or the dictionaries, that will be used to define that knowledge, right? You will use the terms in your dictionary in order to define what needs to be solved. Then we have something that is called artifact repository, where we are going to create different knowledge packages from the different units, right? So you have different departments, and you will be able to version those packages. And then your applications will be able to consume that knowledge, right? And to interact with that knowledge and to be driven by that knowledge. So your applications, they will remain in the same way. They will just need to interact with a couple of engines, like the rule engine and the process engine, that will consume from that knowledge that was already defined and drive the applications. And at the same time, because this is knowledge automation and all the knowledge and all the models are being run by the process engine and the rule engine, you will start getting information about what's happening. So managers can have their information in real time about what's going on in order to make decisions. Do you want to add something there? No?
Yeah, you can look at that as a layers in your system as well. But the most important is that we start versioning the knowledge. So we know that and we promote that it should be flexible, it should be ready to change. But at the same time, we need to make sure that we can run different versions of our knowledge in parallel. We make sure that whenever something new comes up, we can still finish the work on the previous version of the knowledge that it was started on. Yeah. At the same time, the requirements might be yes, but we need to make sure that we promote that work to the latest possible version. At the same time, we can start moving forward gradually without affecting each other. So we have this opportunity to make sure that whenever something changes, we might decide, make a decision if that is going to continue with the knowledge that it has, or it's going to be moved or migrated to the latest possible. So this is where we start promoting this information throughout the running activities as well.
Yeah, and something important, again, from here to understand, it's that it works in a very similar way that we are used to work. So from here up, on all this side, it's about experts working in defining what needs to be done, right? So it allows us as developers to go in there and start learning about how they think that the problems needs to be solved, and the tools that they are going to use are quite similar to what we are used to use. So we have Git, we are going to have something to build those packages, and then we will have something like Artifactory or Nexus to store these packages, and then our applications will use that. So we can reuse the way of thinking, we have a single point there or a distributed repository to work on and to understand what they need to solve and how they want to solve it. And we can bring all that into the automation and in the applications that we are going to build here or that we are going to integrate.
Yeah, so the question we had that who actually use BPM, who knows what BPM is, so BRM as well, Business Process Management and Business Rule Management, is because we are usually starting to think of BPM as something that is big, cumbersome, difficult to work with. And yeah, in many cases, it is a big monolith. The BPM started in like 90s, where everything has to be big, and everything that is supposed to be a BPM-like needs to be expensive in both buying it, running it, monitoring, maintaining, and so on and so forth. So that brings in always the complexity, the long learning curves and technology focus, because then we have to spend a tremendous amount of time to actually understand how to use it. And we have to have a really army of consultants that will actually help us to start with the project. And usually BPM projects start to be like 6 months plus. You couldn't deliver anything faster than that. It's because of the complexity, because of the actual big effort that you need to spend on to actually build something. And that is the traditional BPM, BRM, a huge monolith, a huge installation that requires a really big data centers to operate.
Yeah, and most of the time, it was even worse because it was highly related to a vendor. So if you want to start implementing BPM, you were like quite focused on just a vendor, so you just need to go to a company and buy their BPM and just use it. Nowadays, it's more just like a commodity. You can just use any BPM tool out there. There are tons of open source BPMs out there that you can use. And we do believe that it's just a tool. So the important thing from here is just more like about the concepts and why you should be thinking about using a BPM tool in your daily development against not using it.
Yeah, and the traditional approach to BPM was that it always has to be all or nothing. A platform that you have to build everything there. Yep. Nowadays, when we transition to what we call the modern BPM and BRM, it's completely knowledge focused. So the only thing that you actually care about there is the business knowledge. What the business knowledge is, we will focus in the next slide. But it must be lightweight. We don't have to have it. It even don't have to have the need for application server or a huge data centers for running it. It must be a composable, so it's not like all or nothing anymore. You can see a BPM as one of the components within your application. And the application can use BRM, BPM, integration buses, different data stores, and so on and so forth. It's completely up to your business requirements that will drive the selection of the technology. It must be easy to scale. So it shouldn't require you to have yet another bunch of servers to actually carry on the work. It should be very easy to move the work when there is a need for. And the individual components must be scalable. I mean individual, not that we have to scale everything. If we have a need for scaling certain parts of our BPM, we just scale that element only, not everything else because it's BPM.
Yeah, nowadays with microservices, even your microservice can use BPM. There is no need for you to contact another service. They can embed it there.
Yeah, the microservice can actually use BPM internally. Yeah. It's yet another use case that you either use this as a service, directly as a service, a generic service, or you just expose these capabilities slightly hidden. So you expose your business interface, and you know that inside it there will be a bunch of rules running and evaluating the data that it's consuming. Or there will be a bunch of processes going through, asking for different activities to be carried out. And it could be a user interaction, it could be just automation of the work there as well. And again, it must be adoptable. So whenever there is a change, you should not spend weeks and months of rolling out the change. It should be as easy, just updating your knowledge base, pushing it out, off you go. There is no need for rebuilding entire BPM infrastructure.
Yeah. And think about this, not that just changing or adding a new feature or fixing a bug. This is not about microservices and getting a new version of the microservices out. This is about something has changed in the company, so we need to make sure that that change is applied in the software, meaning that the software now needs to understand about the new situation that is happening in real life.
Yeah, so now what's the knowledge and where is the knowledge? In many cases, when we build our systems, we tend to focus on architecture, on our design, both modeling, UI, code quality, our tests, and so on and so forth. But then we're starting to losing focus on the actual business knowledge. Mm-hmm. And this is where we start having issues. Yep. Because we started to build a software that is detached from the business. Right now we have a perfect software with a full test coverage, with an excellent architecture, with all the models and so on, but it does not really match with what business does.
Yeah, or if it matches, it's hidden completely, so the business cannot understand what's happening there. We are providing a solution, it's a black box. So if you think it as a microservice, we have a service that does something, does some calculations, but nobody can just change those calculations or understand fully what those calculations are. Yeah, and when we start looking at how from the IT point of view or the IT industry point of view, what might be the knowledge in our eyes. So the first thing that is, in my eyes, the most important thing is the data model. And the data model means the entities, the business entities, and it doesn't mean the database model. Because this is extremely important that depending on the technology you use, depending on the data store you use, depending on the language, programming language you use, the persistence layer and your data model might differ. You might have two different services written in different languages using different data store, and they should never aim for having exact same data model for their persistence. Because one of the services can use rational database, but the other will use a graph database. So the representation of the same data model by those services will be different. And then whenever you start thinking about the data model, think about it from the business point of view. Make sure that the relationship between the models are business driven, not technology driven, because you know that with JPA it will be easier to have one-to-many relationship on this entity, and that will be better for me to carry on the work. Mm-hmm. That's not the purpose of the data model from the business point of view. And so this is the what, the things that the business operate on. Mm-hmm. And they should be as close to the actual business entities as possible. And they can be represented in the different formats, like here, the 2-3 examples, XML, JSON, Java, completely up to your technology stack that you're going to use. These are the most important API that your system should be aware of.
not the interfaces of your classes, not the interfaces of your REST or SOAP, JMS, whatever, the data. The data is the most important factor that you will exchange within the systems. Then when we start looking at, we have the data. So something needs to happen with the data, right? The data itself is just the information, but the information will then be used and processed in some kind of way. Then you have to have some rules. Regardless of how you name them, there are things that will drive changes to the data. If, for example, someone is applying for a bank loan, then you have to classify that request. It might be a long-term loan, it might be a basic, it might be just a 5 minutes loan or something like that. Those kind of decisions are again defined by the business. And those are purely business rules. And this is why things happen in the business domain. If we have the data, then we have some rules that will drive those changes. And then, again, that might be expressed in a different format. We have here the rule language or decision tables and so on. We can have different representations of our data. It might be hidden in code like if-else statements, switch statements, and so on and so forth. You might build your own rule engines on top of your data. But anyway, every single system has a decision point. And decision points usually should be captured as business rules because they are clearly defined by the business. What should happen when we have this and this data? If we have a conflict, this is yet another type of rule.
And
Yeah.
those business decisions are the ones that tends to change quickly, or frequently at least. And you need to be ready to change that. So it makes some sense to externalize that from your software and from your development cycle at least.
Yeah, so once we have the data, which is the what, we have the rules that drives the changes, the why, and then we have to carry on the work somehow. And if every one of you who builds the software looks at their systems and looks at the code they've written, majority of the code actually defines a process. If something is given here, then perform this step, this set of operations to achieve a certain goal. And this is actually a process. It's not represented as a flowchart, for example, but it's still a process. It's a set of instructions that must happen to achieve certain goal. And that's actually what business process is. A set of steps, set of activities that the most important thing is to achieve a business goal. And then you can define different paths to achieve a goal. It could be a happy path, that is the most desired path, the easiest one, but there might be exceptional paths as well. And this is, again, a business knowledge that you need to capture, because that will give you the possibility to define how things happen in your system to achieve the business goals. Yeah, the projects that we sort of promote and represent here are under umbrella project called Knowledge is Everything. And then this is a set of open source projects for business automation, business system automation, where the most important parts are the execution. So we have 3 engines. Jules is the expert system, a rule engine that does the rule evaluation plus complex event processing. JBPM is the process engine and case management as well. And then OptaPlanner is the resource planning engine. On top of the engines itself, because yes, we have the capabilities to run business processes, business rules, resource planning in any format. That there are generic engines, so you define your data model, you define your processes and rules that are running on top of this data, but they are generic. So to help actually adopt it, we have a set of tools, and then one of the most important is the key workbench. This is the authoring and management tool. This allows you to capture your knowledge in the predefined format. So you have the processes in BPMN2, rules in the decision tables, decision tree, the rules written by hand, OptaPlanner definition for the planning entities. That's all web tools. So you have everything exposed there, everything is versioned, everything is considered as source artifacts. And the Dash Builder, this is a purely analytic tool for capturing and gathering the data from the execution engine. So this gives us the possibility to actively monitor the runtime and live environments with graph, with data analytics, and so on and so forth. So this is like a base for management and reporting capabilities.
And again, it's kind of like, it's important for us to share about the projects and about the platform in general, mostly because when you start with BPM, you start solving all the problems with the process engine. When you start with rules, you try to solve a lot of problems with rules, and most of the time that's the big mistake. You spend so much time solving problems that are not supposed to be solved with those tools that we strongly feel that we need to share all the platform and why all those tools are together there, and why are we building so much tooling around them in order to simplify the adoption of these kind of methodologies and tools. So Rules is the open source rule engine. It's part of the JBoss community, and it has been there for like more than 10 years now. It's basically a lightweight rule engine that you can start using nowadays in your Java application. You just set up a couple of Maven dependencies there, and that's pretty much it. You can start using the rule engine, writing rules inside your applications, or you can use it as a service. You can interact with the rule engine server that you can start and bootstrap quite easily. You can create those rules in the workbench that we are going to show, or you can just have an Eclipse plugin in order to work in there. There is an IntelliJ plugin nowadays, and there is also a NetBeans plugins, but it's a little bit old nowadays. And then, yes, you have different metaphors to express these business decisions, like decision tables, decision trees, or whatever other way that you want to define those decisions. And again, it's quite powerful because it also allows you to do some complex event processing, which is something that yeah, we can go in detail a little bit later.
Yeah, when it comes to JBPM, you see a lot of commonalities with what how Jules was described. Again, it's the same open source project. It's part of the same umbrella project, Knowledge is Everything. It's a standard-based, embeddable, and lightweight Java process engine. It natively supports BPMN2, and this is the main language for defining process execution. It has the web tooling for process modeling, case modeling, and Eclipse and web tooling for the modeling of the processes. It has a human interaction service as well. So whenever there is a need for a human to interact with the process, we have a predefined task service that is following the WS human task specification. So it's define the data model, define the operations life cycle of the tasks, and so on and so forth. Since it's part of the same umbrella project, we have extremely good integration with the business rules. So once you have a JBPM, you directly have rules in it. So whenever you have a process that requires a decision that is based, for example, on the decision table, you can directly use that from within the process. Process will just put the data into the working memory of the rules engine, evaluate the data, and get the data back to the process. So you have full power of the rules within the processes. Yeah, and on top of that, we have the BPM simulation as well for analytics and analysts play around with the execution of the process to identify where there are potential bottlenecks and issues that might happen with the process. And it's usually very good when you have a set of people working a certain type of task, then you can predefine them, their availability, their working time, and so on, and run the number of processes that you expect on runtime and see if the given task of the given group of people will not be overloaded with amount of tasks. Yeah, and now we start to look at what is actually the knowledge archive. And we know we talked about the processes, rules, data model, and everything. Fine, that is the knowledge capturing. But once we capture it, we define it in the workbench as our processes, so BPM and flowcharts or decision tables for rules, or simple Java beans for our data model. And then what's next? We have captured it. Now we need to somehow make it available for execution. Because yes, we have the data. We have the information. We know what should happen. We know how it should happen. Now we just need to make sure that it happens. So this is where we have the knowledge archives. The knowledge archives is nothing more than a regular Java jar. It's just the packaging of a certain set of resources. It has no restrictions when it comes to types of resources you can put into the archive. It could be a Java classes, it could be all type of business assets like processes, rules, forms, data objects, images, you name it. Wherever there is a need, you can put it in the archive. The only thing that it actually defines it as a kjar is a single descriptor file called kmodule.xml. And this is the only thing to let the engine know that, yes, treat this jar as a certain type of resource that you need to deploy and understand what's inside it.
Yeah, we have worked the last 5 years into adopting all the technologies that every developer knows, like Git, Maven, and these kind of tools that definitely are already into different companies' environments, and we just made that part of the engines. So basically now you can just quickly work and version your things in Git, and then just use your Maven dependency resolution for getting this knowledge inside your applications. Yeah.
All application servers, they support this kjar.
Sorry?
All application servers, they support this.
Yeah.
Yes, as soon as JBPM is running there, yes.
Yes. Yeah. If the engine is running there, and the engine is supported by all the major application servers, so yes.
Yeah, a kjar is a deployment unit for JBPM and rules on the execution servers. The execution server is a lightweight component that you can deploy pretty much anywhere. You can deploy it to application servers. All major components or major application servers are supported, like Whitefly, JBoss EAP, WebSU, WebLogic, Tomcat. You can run it in Spring Boot, you can run it in Whitefly Swarm, you can run it with Vertex. Everything pretty much you can integrate because it's just a set of Java libraries. There is no dependencies to any particular container. It depends on a certain APIs, like for example JTA for transaction management. But besides that, anything that supports that, and you can assemble from a different set of components, from different set of libraries, it will just work.
Yeah. Completely. Yeah. No, it's completely independent.
If you like to run it with VGB, it's supported as well. JBPM exposes a set of VGB services that can be used for tight transaction integration as well.
Yeah, but if you...
Sorry?
Okay, so the question was if it's container independent, and you can just use it outside any container, and the answer is yes. You can use it with CDI, you can use it with the Spring, you can use it with your EE application server if you want, or you can use it with just plain Java SE.
Some people actually run rules on Android as
on
well.
Android as well, yeah.
So then, of course, running JBPM on Android might not be a good idea, but
yeah, you can.
JBPM can run in in-memory mode as well. So then there is no persistence requirements, there is no transaction requirements. So it's really a very skinny version of JBPM. So you have a pure process execution engine without any persistence. So if you have only a short-lived processes, that might be a good choice. But for the typical use cases where you have the user interactions, where you have the integrations with other systems, that most likely requires persistence to make sure that it will preserve the state when the system crashes, for instance. Yeah, and the knowledge archive is nothing more than a jar file, which is under Maven control. It has all the capabilities of a Maven project. It has the same standard structure, it has the same life cycle, and it has the dependency management. Dependency management allows you to set up a project that will require a certain libraries that must be available on the runtime. And that might be any kind of dependency. I would avoid putting the dependencies from the application server, for example, because the application server don't like that. If you're trying to sneak in some libraries that they do not support. But besides that, all the business-related dependencies are definitely supported. The most important is that each kjar on a runtime environment is completely isolated. So if you have a runtime execution server that runs 2 versions of your project, and these 2 versions of the project have conflicting libraries as a dependency, they don't conflict with each other. They're isolated on the entire set of libraries. And at the same time, in addition to that, kjars might depend on another kjar. So it's a composition of your knowledge base. So you can have a common processes or common rules that are shared across the entire domain, your organization, your department, that the scope is to define. And then you have a specific processes or rules for a given department or given domain. Then the common one can be declared as a dependency of your specific one. And then you have access to all the data from the specific one and the common one. They are merged and can see each other as equally important.
Yeah, and then we have different metaphors again to explain and to formalize knowledge. In this case, we are looking at the decision table, which is quite a simple format to represent different set of logics. In this case, it's about how to calculate an interest rate for a credit card. So you basically ask for the person income, you ask for the age of that person, and based on that, you can define what's going to be the interest. This kind of stuff, it's changing frequently, and it needs to be defined by people that doesn't understand all the technical side, so they can take a look at the decision table and start adding rows, start adding more conditions, and then just drive the business using that. So every time that we need to calculate the interest rate for a specific credit card, we are going to use this kind of metaphors to represent how that decision is made. You can use this decision table also to train people, train new people that is going into the company and how the company deals with calculating the interest rate for credit cards, for example. We are going to show this decision table in action in the demo at the end.
Yeah, and this is actually the first step of capturing your knowledge. So you define your rules here, and then you can clearly and visible define that with your business users. It's something that I think that majority of the business people actually use. It is Excel. So they're really familiar with the format. And it's very easy to start defining a set of conditions, and then, okay, if we have these conditions all met, what should happen? But then, okay, we have all met, but then if one of them is not met, shall we do something with that or not? And we start capturing all the exceptional patterns and all the rules that might actually happen to our data. But again, we all start with the data.
This also helps us to understand what the business is requiring, and it also helps us to analyze if what they are asking for us to solve, it's complete and sound, right? We can just come here to the decision table and run a validation tool on top of it and know if they are missing some edges, for example, some age ranges, or if there is some salary range that it's not being covered by the application that it's in charge of dealing with the interest rates in this case. So we can quickly run tools to validate that the knowledge that they are providing is sound and it can be used for automation or not.
Yeah.
Next. The next format is a business rule. This is a little bit more complicated and a little bit more technical, but again, it allows us to represent much more complex situations. In this case, it's quite simple rule, but again, it's showing how you can create a filter for a situation, then as soon as that situation happens, the rule engine will do something for us. In this case, it's a clinical support decision service, clinical decision support service, that basically it looks for the patients and it looks for the history of the patient, and if it has some observations there, then it will recommend something for that. It's quite simple, but that's the main idea of business rules, that you can define a situation and then what to do with that situation. In this case, it's just making a recommendation, but it can be just calling another service, interacting or creating a task for someone, or just starting a business process or something similar.
Yeah, and the quick disclaimer that it's not that we are talking about this hospital and everything. It's not that people using that end up in a hospital. It's just an example. That make sure that you understand that, because it's sometimes when we talk too much about the hospital, people tend to think that it's actually what is in front of them.
And we have a thing. I like talking about hospitals, and he likes to talk about loans and mortgages. So yeah, we just jump between banks and healthcare.
Yeah. So then, yeah, go ahead.
Okay, so the question is if that's a specific language for the rules, or if something that it's, okay, so rules has its own language, mostly because there is no standard rule language nowadays. In business processes, you have a standard language already, but rules, basically the rules allows you to define different languages. One is decision tables, you can also build decision trees, or then you can just go and use the rules, a specific language for writing rules. Different rule engines have different languages, and they all share kind of the same features, but there is no standardized language for that. Unfortunately, yeah, there is no standard for that, but at the end of the day, people end up building like tools to generate this language. So this is like a more technical language to represent complex situations, and you usually build a metaphor on top of that to represent the domain-specific scenarios.
Yeah, the decision table actually upon the compilation of the KJAR will be translated into this. We'll show that example as well in Workbench, where you actually start defining your rules in the decision table. You can jump into a source view where you actually see the generated rule language. There is a work going on to have a POJO rule, so to say. So you start using the Java as a language to write the rules as well.
Yep, definitely. So nowadays it's not there, but in version 7, which is the next version coming up.
Yeah, there is ongoing
yeah.
ongoing effort to actually build that as a pure Java language.
The problem again, that's kind of like contradicting itself. I have like mixed feelings about that. You can do that, but as soon as you do that, that's inside your application. So you cannot decouple the rule that it's written in Java from the application lifecycle itself, because it means that as soon as you want to change the rule, you will need to compile your entire application again and run it, or at least that package that contains that rule definition. So you need to balance that. I mean, sometimes it makes sense to have it there, sometimes it makes sense to have it outside. Like this is a text file where you can just put that, or you can just create different like ways of storing that rule. So yeah.
Yeah, because you can, as we said, the KJAR is the package that brings in your knowledge to the system. And the best scenario is that you should have that externalized. So you can directly promote the new versions of the knowledge without affecting your application. And of course, that is for the distributed approach when you have everything running separately, but you can still go for the, as it was mentioned here with the EGB, you can still have the engine capabilities within your application running as a EGB container components and beans. But then you can still deploy dynamically knowledge archives to it without actually bringing down the application. And if the application is consuming the resources properly, meaning that it can define different strategies. For example, whenever you start a process, always start from the latest version. The latest version available should be picked up whenever I start new process. But if I continue working with an already active process instance, it should carry on the version that it started with, to make sure that it's compatible, to make sure that it has all the versions of the artifacts that it expects to have. And when we look actually at the process as defined in a BPMN, it's a flowchart. A flowchart that has a quite extensive set of activities that define their behavior, like a user task, meaning that if the process goes into user task, it expects user interaction with it. For example, to upload a document or review a certain information. But it could be an automation as well for service execution, business rules, evaluation, and so on and so forth. So there are a number of very important and very powerful predefined tasks. At the same time, JBPM uses the abstract task that is defined in BPMN2 to bring in so-called domain-specific activities. This is up to you to define your domain-specific activity that will be based on a certain set of information that it expects as input, and it defines set of output that it will generate when it's completed. Then, for that given domain-specific activity, you can create so-called work item handlers. The handlers are responsible for actually carrying on the work. And the most important thing here is that it's decoupled from the model. So you define the activity, and on the runtime, you can add the handler that is really needed. So for example, for test environment, you can have a mock handler that will return a predefined set of information. But in production, you might have a work item handler that will actually connect to an external system, like credit card validation. But then you have that on the runtime, so the process actually is not changing. The knowledge archive is not changing. The only thing that changes is the deployment information that you give when you actually put that on the execution environment. One of the issues with the process that people say is that, but yes, it's defined from the beginning till the end. I cannot change it. It's just flow. Everything is connected. So I cannot change it in a given time.
Yeah, This is kind of like a happy path of what needs to happen when we, I don't know, when we need to do an HR evaluation or something like that. But what happens if, for some reason, for that person, we just need to skip one of those tasks, or for that person it's not necessary, or we have an exception, or we have missing data that we found out that when we are in the second task.
Oh.
So what happened at that?
Yeah, or maybe we have to add a new activity that we didn't thought about it before. And for that, we have adaptive processes. They are not defined as a complete flow. They're a set of fragments. And they might be dynamic, they might be auto-started, and even though they look like an independent things, they do share the same context. They see the same data. If a task 1, the user task, will put some information into the process, all other tasks have access to it. At the same time, you can pretty much signal any node in the process at any time, as many times as you want. So if a task 1 needs to be signaled or executed multiple times, you just run it. You just ask the engine instantiate it again. But then if you have a predefined flow of information, then you set it as a regular flowchart with the sequence flows and the definitions of how it should traverse the graph. So you have additional set of information if you make it ad hoc or make it adaptive. At the same time, the case management allows you to create at any given time new tasks that do not exist in the definition. So you can create, whenever this process instance is running, you can say, okay, I need to create another user task because I need to ask for additional information that I don't have in my process. Just ask an engine, add a new task to that process instance, assign that to that people, to that group, or to that set of users. Then it's immediately available for the process engine execution, and it's seen by the end users as well. Even though it was not there from the beginning, it was not there in the definition. All right, enough talking. So what we prepared, and hopefully what will work.
Yep. I think that we will jump just to the second one.
All
You
right.
can show just the workbench and the credit
Yeah,
card application
because we have to switch the computer, so we can
Yeah.
leave the simple knowledge project at the end.
if we have time. Yeah.
Yeah, I think that the most important is to show that what Workbench is and what capabilities it has. We mentioned that the KJARs are the Maven projects. So to have a full running environment, the Workbench is as well a Maven repository. So whenever you build something in your Workbench, it will be available there as in any Maven repository, like in Maven Central, in Nexus. Then those artifacts you can declare in your systems as dependencies. Just by pointing to Workbench as a Maven repository, you can directly get that, including KJAR and its all dependencies. So we will go through the Workbench. We will see the project, the data object, the rule, the decision table, the processes that we have, how they can be built in the system, how they can be provisioned to the execution server. And the Workbench and execution servers are two different runtimes running on different processes. So they communicate only remotely, and Workbench behaves both as authoring and management. So from within a Workbench, you can actually see all the execution servers connected to it, and you can manage their containers. A container is a runtime representation of a KJAR.
Let's take a look at that.
Yeah, and and at the end, we will see the modern business application actually using that. All right, so this is the Workbench, and this is the authoring view. In the authoring view, you have an organization. This is pretty much similar to how GitHub has. So it's just a grouping of a certain types of artifacts.
Yeah.
Then we have the repository. Repository, as the name suggests, is actual repository and a Git repository. All the assets in that repository will be stored and versioned as regular Git repository. So we have everything there. You can integrate your IDE to collect information from, I don't know if you can see that anywhere here. We have the project that is actually checked out from a Workbench. It's the same one that we're going to run. So we have the credit card application that is on just Java Bean. Yep. You can see it here. that is generated by the data modeler. We have the POM XML to identify it as a kjar. Let me see if I can make it bigger.
Yep.
So as you can see, the packaging is of type kjar. So it's a bit changed type of the artifact. And then we have a plugin that is responsible for making sure that the assets in the archive can be already pre-compiled. That is responsible for building the knowledge base for the rules, generating the rules from the decision tables, generating the processes, and making sure that everything can be built successfully later on runtime. Runtime consumes already built artifact. So if you run it with Maven, it will run this plugin to make sure that everything that is included in that kjar can actually be later on executed. So the very simple data object editor that you can just add fields of different types, including the complex types, relationship, lists, and so on and so forth. If you like, they can be persistable by default with JPA.
Again, here is a way to create these models, but you can definitely import yours. So it's commonly that you already have your own models, so you can just import those models and start using them in your projects.
Yeah, and usually you do that as a Maven dependency of your kjar. As soon as you add dependency all the projects to your projects, they will be visible for both rules and processes. You can refer to them as any data objects you have. Most of the editors have the source view as well, so you can actually see what the editor generated. Then we can take a look at the decision table. So it's the same one that we had in the slides. And then when you look quickly at the source, it actually generates this rule language out of the decision table. So you could write them all manually like this, but then it requires a certain amount of knowledge to actually understand the language, understand all the constructs and so on and so forth. While doing that directly on the decision table, you hide this complexity. So you just focus on the actual business requirements. So we have the income that is bigger than 1,000, and then the person is an adult, which is 18 years old or higher, and it's not old-timer, which is below 50. And then we say that if those conditions are met, we wanted to set that it was calculated as a comment, plus the interest rate is 10%. And those are actually represented in the first rule. So where we have the credit card application with those conditions met, we simply update fields on it, and that's it. And the same is the other one, slightly different conditions to make sure that we have a bit different information provided there. And then we have the processes. A very simple one, just the rule execution plus the user interaction to make sure that whenever we place the request for credit card, we calculate the interest rate, we ask someone to actually approve it if it's okay or not. And then we will have a different set of types of credit cards. So then we have a different types of processes. Here we have a slightly more complex, if we can say it's complex, where we have a decision points, and the decision is defined on the outgoing sequence flows. So if we have an application where the age is greater than 20, then it will choose that path. Otherwise, we'll take the other path. So this is where we have additional information provided in the process itself to make sure that we know how it should deal with a certain type of request. So then if it goes here, it will use the decision table. It will insert the application into the working memory. So the rule engine knows that there is an application, and we start evaluating the conditions on it. And if anything matches, it will update the application. Otherwise, it will just go and set a fixed rate that is of 5%. So that is a purely hard-coded information here. And then we have the last type of the credit card type, which is directly with the fixed rate for interest. All right, so we have all this information, then we can...
Again, this is defining the how or the what do we need to solve and how to solve it. Yeah, that's up to the technology. And how we are going to run that, it's up to the technology that we decide to use. In this case, we are going to use the process engine and the rule engine. But again, the important thing and the thing that we want to share the most is the idea of externalizing these kind of decisions in some way. How do you automate that later in the future? It's up to you guys. But if you use these kind of tools, you will get some advantages that Magic is going to show now.
Yeah, and as you can see, since we said that everything is a Maven artifact, we have it here, the group ID, artifact ID, and version as part of our project. So everything is a Maven project. We have directly defined them here as well, so we can continuously version it. We can clone copy the project, so we can have a version of the project with the next version. Since it's a Git, we have different branches as well, so we can use branching for managing our source code as well. So if we say like we did a release of 1.0, we can then move it to a branch and start continuing on the master with the next iteration, but we have a clear state safe on one of the branches.
And again, because it's Git and Maven, you can use any other tools to manage that. You don't really need to use the workbench. You can just clone the Git repository and use any other builder. You can use Jenkins to build your knowledge packages and to deploy them into a different repository. You don't really need to use the tool.
Yeah, actually many users actually start using the CI/CD approach with Jenkins pipelines as well to just grab stuff from Git, build it with Maven, publish it to a runtime, publish it to the Nexus, then trigger a job to publish it to the execution service, and so on and so forth. Since we have everything in Workbench, we can actually start saying, yes, we have our archive, we have our business knowledge, let's start building and deploying it. Start using it for actual needs. So then we use our build and deploy functionality of the Workbench, which will actually produce the jar, put it into a Maven repository, and if selected which server template it should be deployed to, it will automatically provision. Let me see if the server is started. Yep, it is. So let's try this. Yeah, since this is a concrete version 1.0, and there is system discovered that there was already that version built, so it asks if it should overwrite or not. We shouldn't do that, but we do it for the sake of the demo. And then we have our management capabilities. I hope so. Oh, we don't? Oh, we don't. An error. That should always happen, right? So we have our server running, we have our container deployed, credit card application 1.0, it's up and running there.
So important to know at this point, he has a service that contains that knowledge. It means that if you have Java applications, if you have a mobile phone application that is relying on making those decisions, you can just start communicating against that server. That it's publishing all the knowledge and it's waiting for you to send data or send requests in order to start doing stuff. So if you have the application in the phone, it can start calling that server and the server will give you the information back about what's happening, what's the calculation and all that stuff.
Yeah, so since we have our knowledge capture and our knowledge built and provision to our execution environment, now it would make sense to actually start using it, right? So what would be the thing that we would use to consume that? In the old days of BPM, it would be included in the BPM, in like Workbench. There will be a set of screens saying, yeah, do this, and a generic process instance list, a generic task list for everything inside that execution environment. But to go on with this modern approach and make sure that everything is tailored for a given domain, everything that is prepared for working properly and working only in that domain, we have a simple application that is written in AngularJS just to make sure that you can use pretty much any language to interact with the process engine and the execution servers, where you have a bunch of forms that allows you to place requests for the credit cards. We have predefined 3 types: Red Hat, Community, and Master Tables. And as you could see, we had in the domain modeling, or in the knowledge capturing, we have three processes defined for different types of cards. They will follow different flows in the process to make sure that they get approved. Or for example, they will have different types of calculating interest rates. But at the same time, if the calculation of the interest rate will be done by rules, we will use the decision table there. So now we remove the complexity of deciding what credit card rules should be applied and how they should be actually carried on from our application to our knowledge archives that defines this, how it should work. So then we can select a certain type of credit card, and we just simply need to fill in a very basic form. I'm young, so I'm 22. And I just started. So I just place the request, and we can place at the same time. Request for community card for Mauricio. Income.
Not so much.
20,000. 20,000.
That's good.
Age 45. Especially for you, my friend.
That's good.
And then we can look at the process instances, just to visualize that we actually started something. So we have that there are different processes started.
So, interesting thing to mention here. So this is a process instance list. This is a generic way of looking at what's happening with our systems. This can be used to make decisions, saying, okay, we are dealing with so much credit card transactions that we don't have enough people to deal with that. So that can help us to say, okay, let's make a decision, let's bring more people in to evaluate those transactions or those requests. And at the same time, it can be used also for like administrators to solve problems. So someone needs to interact with that request for that credit card because it's a specific situation. Okay, so we can go and take a look at that.
Yeah, so we have that, we know that the different processes, it's as Mauricio said, it's more of a administration interface to show it that, yeah, we have the instances running there. So if you wanted to, for example, see what process it is, we can visualize that as well and see directly where it is. So we know directly on which activity it waits. So here's for Red Hat, and this is for community. And then to be able to work on it, because we know that it's waiting at the approve user tasks. So we can just go to the task and we directly see we have 2 of them. So we can just claim them, can claim all of them, and then view. And let me make this. So we know that the community one has no business rules attached. It uses the hard-coded rule for interest rate, which gives the low interest rate for community members. So that's 5%. Come on. And then if we go back to tasks, take the other one, see it calculated interest rates based on the conditions, that income, which was more than 1,000, and the age, which was the adult, between 18 and 50. So that can give us directly information that what actually happened, and without having the information hard-coded in the system, this is completely delegated to the execution servers that know knowledge, know how to apply the rules, know what the processes that should carry on the work. Although you have the complete steered application and tailored application for a given use case. It's not like a generic view, like you have this processes, because that would be fine. We can kind of create forms that will just purely show in the big BPM scenario. But then if we don't have this custom application, we cannot apply security constraint that we want. then people will start asking, okay, I need to make sure that end users going into the BPM environment will not see the authoring. They should only see the tasks. And then we start make the environment very complex because we start putting more and more responsibilities on a single component. By delegating that into individual components, we can actually scale them. So let's say that we have this credit card application, which is extremely frequently used. And we know that there will be rules and processes running every millisecond. Then we know that single component will not work with that. But at the same time, maybe the UI is actually powerful enough. So we might want to have a single instance of a UI application and have hundreds of instances of our execution servers. Those then are load balanced and performing all the operations requested by the application.
And from the business knowledge point of view, I mean, if you go to the first screen, today we have 3 different types of credit cards, but tomorrow we can just remove one, or we can just add a new one. And in order to support that, we will need to go to the backend and we will need to define the knowledge on how to deal with that new credit card. And that's it, basically.
Yeah, and this application directly talks over REST services to the execution engine. And it always uses the latest version of the cager. So if we build a new version, as Maurice just said, we add a new credit card. We just need to make sure that there are processes to carry on the work, and maybe the rules needs to have additional conditions to deal with that card. But then the application does not change at all. They can still put it, okay, just use that rules for that card, and that's it. And just send the application, which carries on the information, what kind of card it is, what data we put in, and we can create, for example, instance of this.
And again, for us, it's really important to share this idea of decoupling the cycle. You can just go and create how to deal with the new credit card without touching the application, and as soon as everything is ready to deal with that new credit card type, you can just go and add an extra button in your application, and that's pretty much it.
Yeah, and then we had the third type of the card application that uses the most advanced process that uses the decision to either use the rules or use the fixed rate. In this case, it used the rules. So if you go here, claim, and view the task, that was executing the exact same rules because it was below 50. So if you create an application for the so-called old timers, which is the age more than 50, then it will be the 20% of the for the interest rate. We can create that as well. Yeah. Everyone is from JBPM. 55. And then we have the interest rate set to 20 because the rules, different rules apply. So this is how you actually start building the business-driven applications, that you have the knowledge captured, knowledge separated from the application, and you can individually expand and evolve different set of components that you work with. And of course, in this demo, we show that the application is purely based on the knowledge that is in the backend. But at the same time, it might be that just the half of the application requires the business knowledge to actually perform. The different things might happen within the application that are not driven by the business. It might be the persistence of the data. It might be different views, different reports, and so on and so forth that the application generates. But it does not use the knowledge out of the execution servers.
Yeah, one really important thing is that these kind of technologies are not intrusive in the sense that you can use your own models. You can start small, and you can start adding the things that really matter and add some value on top for the business. So there is no need to go and just create all your applications using rules and processes. You can start small with a very simple problem and start integrating these services against your existing applications. So again, it's going back to the beginning when we were saying like start small. It means just pick a small business problem that you have, try to model using some simple rules and some simple processes, and just start with that. That part of the application will start consuming the knowledge from there. but the rest of the application can keep working in the same way that it was working before.
Yeah, and as the last comment is that this approach promotes the way of thinking about the aggregated UIs. Is that you start building systems that might consume different services within the same UI. So you start building a system that looks and feels exactly the same to cover the entire business process. Because, of course, depending on the domain, the business process might be as simple as just a bunch of process definitions, but it might be that the process definition will be actually layered or hierarchical. That the huge business, for example, car manufacturing, is not a single process. It's a really set of processes. And then if we have the same audience in our business, on our business side, we would like to have a system that looks and feels exactly the same, regardless of what part of the process you work with. So this actually promotes this way of building systems, because you start delegating the execution to a backend, and then you start focusing on providing the UI entry point to those executions to make sure that they look and feel exactly the same. You want to show this simple project, or we done? Yeah, we're running out of time anyway, so. All right, so I guess that quick concludes the session. Go to presentation. Yes, sir.
There is some links.
Yeah, that's what I always forget. Yeah, but we have questions first. If anyone has any questions, any comments, feedback, whatever. Yes.
For troubleshooting, is it logged?
Yes.
Can you usually see what rules were triggered?
Yeah, the question is what tools we have for troubleshooting. And there are really a lot of tools that you can use. We have good integration with JMX and MBeans. So this is the first thing that you can start as a monitoring rather than troubleshooting, to make sure that you see what executed, what's happening. For processes, we have the pure business activity monitoring, so everything is logged in the database. You can use Dash Builder to look at what actually went there. This is the way as well you troubleshoot whenever something failed or something went wrong. And at the same time, each engine supports event listeners. So you can define your own event listeners if you wanted to capture different things that happens in the execution. Like, for example, what rules were activated, what rules executed, what process was executed, what nodes within the process was executed, what life cycle operation of a task has been executed as well. So those kind of information you can capture and troubleshoot with the event listeners.
Yeah, it's even for both, right? So you have like the business monitoring part of it, the business information that it's important and it's being captured by the engines, and the more technical side of it. And the business side, it's both for the business and for the technical side. The good thing about that is that you can start reacting on top of that information. So as soon as you started 10 processes or 10 rules were evaluated for some scenario, you can start notifying some other applications about that. And then just start communicating or integrating based on the business activities, basically.
Correct. Any other questions? Comments? Greetings? All right, thank you very much. And here we have the community links where you can find more information, where you can find us at the RSC channels for Jules and JBPM. If you like to read more about what's coming, what's being developed, and if you have anything to add, share, you know where to find us. Thank you.